All right, I will begin.
Let's go.
I'll begin with a word of prayer. So, dear Father, we thank you for this day. Again, I thank you for this class, for these students. Just ask you just bless our work today, help us to glorify you what we do, and just understand a little bit more about your creation, Lord. I just pray again that you'd encourage the students, if they're struggling, just to do their best each day, Lord, for your glory. In your name I pray, Lord Jesus. Amen.
Amen.
All right, so I guess I should probably hand this attendance sheet out again. Let's see here. Yep. Any questions before I get started here?
Should I put the date on the attendance sheet?
Oh, I already got it there.
Okay.
It's at the top.
Pass. Sorry.
Looks like I need whatever from your
So, we've talked about one-to-one functions, we've talked about inverse functions, and we've talked, of course, about exponentials and logarithms. We have more exponential and logarithmic equations to solve, some examples to go over that we haven't done yet. So we'll do those. But I think I want to start class today with a kind of a combined concept question, which is how do we find the formula for a function if that function, if the formula for the function maybe involves exponentials or logs, all right? So we found the formula for inverse function when the equation for the function was pretty much just a rational function or an algebraic function. But we could also deal with something like this. Say f of x is equal to 3 plus 2 e to the x minus 7. All right. We can prove that this is a one-to-one function. All right. So what I'd like to do then is to find the formula for the inverse. Let's find the formula for the inverse function. Let's find formula for f inverse of y. So how should we do that? What's our opening move? Remember what we do? We put y equals to?
Y equals to 3 plus 2e x minus 7.
That's right. Michael is correct.
And switch out the x.
I do not switch out the x. I just solve for x. So
No. What I mean to say is replace x with y. I moved x to the left.
yeah, I don't do that. I solve for x now. So
Oh.
yeah.
Tricky.
You can replace x and y at this point if you want, but then you'd be finding the formula for f inverse of x. All right, so next our goal is to solve for x. So we want to isolate x, right? So to start with, I'm going to go, okay, so I've got y minus 3 is equal to 2 e to the x minus 7, right? Now I need to isolate the exponential as well, though, see, because 2 times an exponential, I don't have anything terribly nice for that. But if I divide both sides by 2, then we're almost home free. Y minus 3 over 2 is equal to e to the x minus 7. Right, divide by 2. All right, now how do I get the y? How do I get that x out of the exponential? What do I want to do here now? Yes, Michael.
The logarithm
The log.
the base of e.
Take the log base e of both sides? I mean, I think that sounds like a good idea. So what we should do is we should take the natural log of this equation. So I'll do it up here. We take the natural log of y minus 3 over 2 is equal to the natural log of e to the x minus 7. But you see, the natural log and the exponential are inverse functions. Okay, so the right-hand side of the equation I just wrote in blue, it simplifies simply to
L1.
just x minus 7. X minus 7.
ln e is 1.
That's true, ln of e is 1. Now, so I can solve for x. And what do we get? X equal to
X is
7 plus the natural log of y minus 3 over 2. And there you go. That is the formula for f inverse of y. So there it is. F inverse of y is equal to 7 plus the natural log of y minus 3 over 2. Can you tell me what's the domain of f inverse, by the way?
F inverse.
Yeah?
The domain of f inverse is 3 to negative infinity 3 and 3 to infinity.
Ah, but if I put 0 in there, I'd get the natural log of minus 3 over 2. That doesn't work.
Oh.
I mean, we need y minus 3
F
over 2 to be greater than 0.
1.
So that is the same as...
Oh. 3. So 3 to infinity.
Yeah, 3 to infinity, 3 not included. All right? And by the way, what's the range of the original function?
Y and y isn't equal to 3.
No, the range of the original function is also 3 to infinity.
Oh, interesting.
And if you look at the formula for the original function, you can kind of see why that is, because what it is a shift of the exponential 7 units to the right and then stretching it vertically by a factor of 2 and then shifting it up by 3. So if you shift it up by 3, you move the horizontal asymptote at the y-axis, x-axis up to 3. And so it goes from 3 not included to infinity for the range.
So it's the same as x.
The same as x. I'm sorry? What's the same as x?
The domain of x.
The domain of f inverse is the same as the range of f. So now what's the domain? What's the domain of f? By the way, the domain of f, there's no restriction, right? That makes sense for any x. So the domain of the original function
Negative infinity to infinity.
minus infinity to infinity, and that would also be equal to the range of the inverse function for what it's worth. So my original question wasn't asking about domain and range, but I think it's interesting to kind of stop and look at that while we're at it. Should we work another example? Let's do one that looks, let's do one that's kind of the opposite way around. So example 2, suppose you've got f of x is equal to log base 7 of 3x minus 2. We'd like to find the formula for the inverse function. All right? Now the good news is that question makes sense because, in fact, this is a one-to-one function, so it's a reasonable question. And how do we do it? The same way we did the previous example, all right? First of all, we write y equals to the formula. And then we solve for x. So we'll start by writing y equals to
log base 7
of,
times 3x minus 2.
so now solve for x. So the next thing I'm going to do is, let's see here, I've got a log base 7 on both sides, right? Well, not both sides, but on one side. So the natural enemy of the log base 7 is 7 to a power. So I get 7 to the y is equal to 7 to the log base 7 of 3x minus 2. But that is 3x minus 2, because log base 7 and the 7 exponential base 7 are inverse functions. Now I just need to solve for x. Can you do it? We get 3x is equal to 2 plus 7 to the y. I add 2 to the other side, and then I divide by 3. And that is the formula for the inverse function. So f inverse of y is equal to 1/3 2 plus 7 to the y.
So to solve for x, you need to divide 3 on both sides.
That is true. Yeah. Yes.
Do we have to write it with the 1/3 on the outside, or are we allowed to leave it over 3? When we divide by 3.
Are you asking if you can also write the answer like 2 plus 7 to the y divided by 3?
Yeah.
Yeah, that's fine. That's the same excuse me, same answer. Just a question of format. Sure. How about this? What's the domain and range this time? What's the domain of f inverse here?
Good question.
Okay. What's the domain of f inverse? Is there any way to break this formula? 7 to the y power makes sense whether y is positive or negative, right? Exponentials have domain of everything, and when you add them and divide by other numbers, it's still just everything. So like
Negative infinity to infinity.
right. And that, by the theory of inverse functions, is equal to the range
Yep.
of the original function. What's the domain of the original function? How would we figure out the domain of the original function? What do we need? We need the input to the logarithm to be positive, which is to say 3x is greater than 2, which is to say x is greater than 2 over 3. So the domain of the original function is in fact 2/3 to infinity. And that will, by the way, be the range of the inverse function, although that's less obvious. Although it's kind of obvious if you look at the formula, right? What happens with this formula? If you look at the blue formula here, what happens with it? As 7 gets really, really negative, really, really large and negative, 7 to like minus infinity is essentially 0, all right? Don't tell the other math professors I wrote this, but this is true. All right, and don't write that in your calculus class because they'll take points off. But it's true. And so since that's 0, when you go to really large negative values, this just goes to 2/3, right? And then on the other hand, if you take large positive values of y, it goes to infinity. The point is that this expression can reach pretty much anywhere from 2/3 to infinity. But it doesn't actually get to the 2/3 because the 7 to the y is never actually 0. It's just getting closer and closer to 0. So anyway, yeah, the range is 2/3 to infinity. That makes sense. But that's not how I figured it out. I figured out the range being 2/3 to infinity by asking the question where the formula for the domain, formula for the function given doesn't make sense. Okay, anyway, I think I've belabored this point about the interrelation between the domain of the function and the range of the inverse function and vice versa, right? I think I've said this about a dozen times in here at this point, so I'm gonna lay off of it. Any questions? Yeah, yes, Michael.
Can you give me an example on how to solve problem number 124?
Find the formula for the polynomial f of x equals ax squared plus bx plus c.
Yeah.
Graph contains points.
So
0,
I'm
10, and 14.
So I'm going to put off talking about that today because that's actually a good question, Michael, because past a certain point in the homework, those are actually review questions for the final exam. And that one is an example of a review question for the final exam. So at mission 3, it's like new material up to a certain point, and then past that point, you'll start running into like stuff from the first third of the course and the middle third of the course. So like mission 3 actually has review for final exam problems. That's one of those. So I'd like to come talk about that later. I'm trying to focus on the logarithms today. So let's look at a different problem. We haven't looked at one like this just yet. What if I have, say, log of 3x squared minus 8 equals to 10? Can we solve this equation? And how should we do it?
So we know it has log with a common base.
Ah, yeah, so you're like, this is the common log, that's log base 10?
Yes.
Very good. So how do we get rid of it?
Log, natural log on both sides.
Ooh, log of a log. No, log of a log is not helpful.
Natural log.
Natural log of a log also, I don't know what that is. I mean, I know what it is, but it doesn't like simplify.
Oh, take both sides to the power of 10.
There we go. So 10. Oh my. Oh. Oh my.
You make it oops?
Is that wrong?
It's not wrong. It's just big. So why not? Okay, so 3x squared minus 8 is equal to apparently 10 to the 10, which is a big number. But we can solve this nonetheless. This you definitely don't want to probably put in your calculator. I mean, you probably better just leave it like it is. So we've got 3x squared is equal 10 to the 10, which is, you know, big. It's just what? It's just, isn't that, that's just 10 times 10 to the 9, isn't it? It's not that big, is it? Yeah? I mean, 10 to the 10 is just 10 times 10 to the 9, isn't it?
1e10.
So that's just 10 billion. It's just 10 billion, right? That's what? That's like less than 1% of the federal budget. The federal budget's a couple trillion. This is pennies. I think we gave 10 times that much to fund the war in Ukraine last year, right? For example. Didn't we give like 100 billion to that? I think. I don't follow the news that carefully. So x squared is 10 to the 10 plus 8 divided by 3, also known as 10 billion and 8 divided by 3. And our solutions are plus or minus the square root of 10 to the 10th plus 8 divided by 3. So there you go. Hooray, we solved it. Now, just a second here. Whenever you're dealing with a logarithm, we should think about, does this actually, are both of these legitimate solutions? Have I found an extraneous solution here? What do you guys think? What happens when you plug both of these in? They give you what? Log of 3x squared minus 8 equals to what? Log of, by construction, 10 to the 10.
Log
right? Because undoing the quadratic equation, that's the x such that 3x squared minus 8 gives me 10 to the 10, right? And as such, log of 10 to the 10 is equal to
10.
10, yep. So the thing we ran into with the extraneous solutions doesn't happen for this problem, right? Let us solve another problem. All right, example 4. What if I'm up against, let's say, the natural log of x minus 3 minus the natural log of x plus 2 equals to, I don't know, 3. Can we solve this? What do you guys think? What property of the logarithm should we use to simplify this one? So the name of the game when solving equations with logs is to try to put everything into one log. Yes, Michael?
So ln is x minus 3 divided by x plus 2 equals ln 3.
Well, I can't just change the 3 to an ln 3, but I can leave it as 3. That's true. Now, if you want to...
Sorry.
You're fine. You're fine. So 3, now, if you want to write 3 as a natural log, how would you do it?
Insert the e.
Insert the e. Well, I can do this. I can say that's equal to the natural log of e to the 3. That's an identity which is true. And so anyway, then the logarithm has the one-to-one property. So the only way that can be true, right, is if x minus 3 over x plus 2 is equal to e to the power 3. You notice that's the same equation, the thing I just wrote down in red. That's exactly what we would have got if we just exponentiated the equation. Do you see that? If I just exponentiated, take this equation right here and like raise both sides to the e power, I mean e to this equals e to that, that gives me this. So exponentiating the equation gives me this. But that's equivalent to using the one-to-one property and the trick I did over there, exponentiating both sides. Or if you like, I can just look at this equals to that, and I use the one-to-one property. However you want to see it, we get to that. Now how do we solve that?
So multiply x plus 2 to e3.
Okay.
X minus
So Michael, what's your larger goal here? What are you trying to do?
x minus 3 equals e cubed times x plus 2.
Yes, but what are we trying to do? What's our goal at the moment? Our goal is
Isolate x.
isolating x, right? So this gives us e to the cubed times x plus 2 e to the power 3. Now we put all the x's, bring all our x's together. like a greatest hits Taylor Swift album. Let's see here. Sorry, is too soon? No. Are you a Swiftie?
No.
Okay, just checking. They're among us, you know. There could be one here. So, I don't know, which is worse, a Swiftie or a believer? Don't, no? A believer. So stupid. Oh, goodness gracious. Can't we have our own identities? Must we siphon them off celebrities? Let's see here. X times 1 minus e cubed. Have I done that right? I hope. And so finally, finishing blow here, x is equal to 3 plus 2 e to the power 3 divided by 1 minus e to the power 3. If I didn't make a mistake.
Oh.
So what do we got? So I'm curious what the decimal approximation for this is. Let me go get my calculator and find out. See, because we did make a step here, we made a step where we combined logarithms. Whenever you make a step that combines logarithms like we did, there's a chance that we have joined, we've included an extraneous solution, in which in this case, it could end up meaning that there just is no solution at all, even though this appears to be a solution. I'm not sure. So 3 plus 2 times e to the power 3, I get a 43.17-ish upstairs. And I get a minus 19.09 downstairs, which is approximately, what do you say, Michael?
Negative 2.26.
Yeah, minus 2.262, let's say. Question, is that disqualifying? Or is that okay for our original? Is that in the domain of the original equation? All right? Is this in the domain of natural log of x minus 3 minus the natural log of x plus 2 equal to 3? How do you define the domain of an equation? Well, what we mean by that is the domain of the expressions that are forming the equation, right? So, ooh, ah, ee, no. To quote my community college professor, this dog will not hunt. You know, we're out of luck here, because minus 2.2 minus 3 is a minus 5. That's definitely negative. That's not good. And even this one, minus 2 over 2.6, you know, that is also, they're both negative. So in fact, this is extraneous. The answer is?
No solution.
No solution. Oh. Well, all that work for no solution. So here, let me show you how to get a solution. If instead of this problem, we looked at the natural log of 3 minus x minus the natural log of minus x minus 2 equal to 3, well, guess what? That would give us the natural log of 3 minus x divided by minus x minus 2, also known as the natural log of x minus 3 over x plus 2 equals to 3. And then at that point, what happens? It's the same song and dance as we just went through for example 4. See, my example 5, my point in example 5 is this right here, my friends, is this, it gets you to the same equation right there, right? It's going to get you to x minus 3 over x plus 2 equals, then you do the quadratic, and we find our solution of minus 2.62. How about now? Try that on 3 minus x. Try that on minus x minus 2. What you got? About 0.8. And you got yourself about 0.262, right? Both of which are positive. So the solution that we found is in fact a solution to an equation which is related to the one we had an example for. It's just that one. Any questions? So sometimes we get no solution. It can happen. Do you guys want to look at a picture of why there was no solution? We could do that. Yes, Michael?
Yes. For problem number 112, is that a review question?
I don't know.
Match by filling in the blanks with the appropriate choice of A, B, C, or N, where N...
Oh, no, that one's not. We can talk about that one, sure. Now, that one's like the ones I did the other day with a expand or collect the logarithm.
Yep.
So, yeah. Let's see here. Any questions about example 4 and 5 before I go on? No? Okay. So Michael's referencing, there's a problem in the homework where I have like a few different expressions, and oh goodness, Michael, I can't remember the format of that question off the top of my head. Let me project it. I'll project the question, then we can talk about it. While I'm getting that all set up, let's work a different example.
Let's...
So while you guys are waiting for me to get my computer out and get it back to life, let us solve example 6. Example 6. I'd like for you guys to try to solve x to 2 to the x minus 3 is equal 3 to the x plus 8. See if you can solve that. So what's your first move, people?
Natural log.
Take natural log of the equation. That sounds like a winning proposition. Let's do that. So we've got the natural log of 2 to the x minus 3 equals to the natural log of 3 to the x plus 8. That gives us x minus 3 times the log of 2 is equal to x plus 8 times the natural log of 3. Which then you can multiply out, right? And collect all the x's together.
So do I need to divide and cross out the ln's?
Oh, you can't divide out those ln's. Although that is something that will be featured in my math prank channel. It's exactly the kind of step that I'll be featuring. Only wrong steps all the time, but plausible wrong steps. Reinforcing students' worst habits, that's my goal. But no, you can't cancel. The logs are numbers. This log is, think of it as being glued to the 2. There's nothing you can do about it practically. Like those are numbers. You have to deal with them. And so we've got like log 2 times x minus 3 log 2 is equal to log 3 times x plus 8 log 3, which gives us log 2 times x minus the log of 3 times x is equal to 3 log 2 plus 8 log 3. And you might be, the parentheses are optional here. I just tend to write them. Anyway, so factor the x out, right? Factor the x out. And then what? Divide, right? So answer? 3 log 2 plus 8 log 3 divided by log 2 minus log 3. We did one like this the other day, but it never hurts to do another one, so there it is.
So hold on, let me get this.
Okay.
So glue ln 2x minus 3 ln 2 equals.
I'm finding my way to your problem, Michael. Oh, here. Problem one.
Trust me, I'm trying to stay focused and relaxed as I possibly can.
Okay. Don't be too relaxed.
No, I'm just keeping a minimum.
Okay. That's my problem. Is I get too relaxed and I fall asleep and I don't get what I was supposed to get done. Happens a lot. I have a very comfortable chair at home. It's the source of much of my sloth. I blame my wife. She bought it for me years ago. Although I'm grateful for the chair. Are we good on this example? We're getting there? We're almost there. But honestly, if you have the right idea, take the natural log of the equation and then you just chase out the details of that carefully, then you'll have that problem solved correctly. And that's really all there is to it. But carrying out those details carefully does require some care. That is true.
Got it.
Okay.
But don't worry, I'll soon learn it.
All right, so let's look at Michael's problem 112, right? How does this problem work exactly? What's the idea here? We've got log of x plus log of y squared minus log of z. And we've got 3 plus log of x, so we got the natural log of the square root of this stuff, right? And then you've got these various options, simplifies. So the question is, how can you simplify those to match up with these things down here, right? So how do you solve a problem like this? Well, what I would do is I would start with what I'm given, a, b, and c, and I would try to simplify it, right? And then I would say, oh, well, is that any of my options? Because if it is, then I know where it goes, right?
Yeah.
So can you guys tell me how would I simplify part A?
Combine.
Combine.
Log x plus y squared minus z. That goes for A1.
Just a second here. I may agree with you, Michael. So that's the common log, right? That's log base 10 for one thing. So log of x plus the log of y squared minus the log of z. So what can we do here? I can combine it into a single log, right? Of x
Plus.
Times y squared.
Oh, divided by.
Yep,
Z.
divided by z.
Oh, so it's n. Nope.
So that's one of these here, isn't it? Right? That's this guy, right? Okay. So that's one way that simplifies, right? How about, let's talk about 3 plus log x. Can we simplify that one?
So I'm guessing log. Oh, man. The notebook.
So let us use an identity. We can rewrite 3 as log base 10 of 10 to the 3.
Plus log y.
Right? Do we agree? So this is just, if I want to rewrite 3 as a log, that's how it goes. And so then that gives me the
Log 1000 x.
yeah, 10 to the 3rd times x, which like you said is log of 1000 x, which I think is one of my choices. Yeah, it's, well, 3, right? Well, b goes in 3, right? B goes here.
Yep.
Yeah. Do you guys remember the change of base formula? What would the change of base formula say? Do you remember?
Change of base.
So change of base formula,
Oh,
for example, natural log.
I think I still have my formula sheet.
For example, log of a is equal to the natural log of a divided by the natural log of 10.
Change of base form.
There's various forms of the change of base formula, but one base, if you want to change to natural log,
Oh, log of a of x equals log b of x over log b of a.
so if we apply the change of base formula here, what's that look like? Think of a as being your 1000x.
Log a.
We have natural log of 1000x divided by the natural log of 10. See, because the log is log base 10 here, right? The common log. Oh, that's one of these, isn't it? So apparently b goes both in part 3 and in part 5, right? So anyway, I'm going to stop there. I do want to leave you guys something to do, you know, but that's how you do these. Just simplify and try to match. Okay? Does that help?
Yep.
Okay. Good.
So 1, I believe, is n.
1 is, you believe 1 is n? What do you guys think? Do you guys agree?
Come on.
So Michael is saying that 1 is n. So it's possible that this is none of the above. All right? If I'm putting none of the above as an option, you're probably going to use it somewhere. Okay? So how could you be sure that how could you be sure that like part 1 is none of the above? Well, one game you could play is just try putting numbers in for x, y, and z and seeing if it matches up what the formulas give you when you put the same numbers in for x, y, and z, right? Like, what happens if I put x equals to 10, y equals to 0, z equals to, let's say x equals to 10, y equals to 1, z equals to 1. See what happens there. If I put x equals to 10,
Log of 10.
oh, that might be misleading. Just because you get the matching doesn't mean they're equal either. Well, anyway, I'll just say that Michael might be right.
I'll just go put it down anyway.
Okay, you do that. Anyway, guys, so we got a quiz on this stuff, what, Wednesday? And I'll try to work more problems on Friday, most likely. Thanks, everybody.